So today we're going to learn about how to remove a node from linked list, and this linked list will be a linear linked list, right? So very simple and very easy to remove. So yeah, let's look at the concept. So in the linear linked list, we will look for the target using the element, like the data itself, comparing the data itself, right? So if it's the head, then it will be all of one, and easily it can be removed by reassigning the head into the next node, which will be B, right? So if it's not the head, then it will have to traverse through the linked list, and once we find something like if the target element is C, then we'll have to reassign that the B next linked into the D, and then garbage collector will take care of the target element, which is C. So that's what the linear linked list look like, how to remove it, right? So okay, let's go to the code and let's implement that concept in here. So first thing first, we'll have to create a current node, and that will be equal to the head, and it will copy shallow copy. I think that's what the term is. So it will copy it, and then verb previous, and then node, and we won't initialize anything, but later on we will have to use that variable. So yeah, and first thing first, we have to compare the current node dot element, and we'll compare that element, and then we'll have to, if they are the same, and then we find the elements, the target element that we're trying to delete. Right here, we'll say, hey, head equal to current node dot next. So that will remove easily. So that's all it takes. The garbage collector will take care of that, and then the head will be the new link, the new nodes. So if we couldn't find the target node in the head, then we'll have to traverse. Okay, so while current node dot next is not equal to null if it's not the end of the line in the links, and current, and we couldn't find the element on the list, then we'll have to traverse. Right, and we'll have to store before that. We'll have to store the previous node of the current node, so that once we find the target on the linked list, we can remove the target from the linked list. So if current node dot element is equal to element, right? So, and then previous node dot next will be equal to current node dot next. So so you will get the concept right here, right away. See, previous node will be the node before the target, right? So that will be linked to the node after the target, right? So it will be A linked to D. B linked to D. B linked to D. So let's see if this code works or not. Control and enter. And yeah, we have some things, mistakes right here that we forgot to take care of. Oh, okay. We need to decrement the length of the linked list. So basically, after this, we have to still compare current node dot next. Element and triple element comparison, and if they are the same, then we'll have to decrement it. So current node doesn't change; it will be the target node, always the same. And because we found the target node here, so uh, the first condition or the second condition, it will be the same target if we found it, right? So the length will decrement anyway. So here we decrement it, and let's see it works or not. So control and enter, and there we have it. So it will work, and this is how we remove a node from linear linked list.